Good day. So let's look at the question today under educational statistics. So let's read what the question says and let's see how we can find solution to the question. The question says the frequency distribution for the number of minutes. Please take note of the time. Time is measured in minutes per week spent study statistical method by 330 NOUN postgraduate students as contained in the table below. So time study, take note, is in minutes, number of students who study at this period of time. For 30 to 39 minutes, we have 140 students who study at that period. 40 to 49 minutes down to 90 to 99 minutes. So this time spent in statistics, we refer to them as class interval. That's what they are called, class interval. Now let's see what the question says. So using the table, find the following. 1, the class size of the distribution. 2, the upper class limit of the 5th class. 3, the lower class limit of the 2nd class. 4, the class size of the 3rd class. The class mark of the 3rd class. 5, the lower class boundary of the 4th class. 6, the upper class boundary of the 7th class. Then 7, the relative frequency of the 1st class to 3 dp, decimal place. 8, the percentage of students who study statistical method for at least 59 minutes. 9, percentage of students who study for at least 1 hour, and 10% of students for less than half an hour. So let's see how we can put an answer to these questions. Question 1 says we should find the class size of the distribution. So let's first of all understand what is a class size. A class size is the difference between 2 consecutive class intervals. Is the difference between 2 consecutive class intervals. This class interval and the class interval, they are consecutive. Why? They follow each other. So you cannot determine your class size with 30 to 39 and 50 to 59. Because 30 to 39 and 50 to 59, they are not consecutive. It's only 40 to 49 and 50 to 59 that is consecutive. The same is true for 50 to 59 and 60 to 69. That is, I continue like that to the last class interval. So the class size is the difference between 2 class interval. While doing it, you can use the lower class versus lower class or upper class versus upper class. But you cannot use lower class versus upper class. So the difference between 2 classes, whether lower or upper, is what we call class size. So let's see. Now I will put an answer to that. So Roman figure 1, my class size is simply 40 minus 30, or I'm using the lower class interval now, 40 minus 30, or I may choose to use the upper class, 49 minus 39, or 49 minus 39. So the result is simply 10. So this is how you calculate your class size or class interval. So Roman figure 2, so our class size or class size is simply 10. Roman figure 2, so we should find the upper class limit of the 5th class. So what is the 5th class? Let's count. 1, 2, 3, 4, 5. So this is the 5th class. So the upper class limit of the 5th class is, I said earlier, this is the lower class, while this is the upper class. So that will take us to Roman figure 2. So the upper class limit of the 5th class is simply, as we said earlier, this is the 5th class. So this is the lower class, this is the upper class. Our answer is simply 79. Then let's go to Roman figure 3. You say the lower limit of the 2nd class. So this is the 1st class and this is the 2nd class. So the lower class limit here is this first number. So Roman figure 3, the lower class limit of the second class. Let's go again. Second class, this is the first class, this is the second class, this is the lower class, this is the upper class. So you can tell directly from the table, our answer is simply 40. Our answer is simply 40. That is the lower class limit of the second class. The Roman figure 3, we are asked to determine, sorry, Roman figure 4, the class mark of the third class. The class mark, take note, class mark, we have class size, we have class mark of the third class. So who's the third class here? Is 50. The third class is 50 to 59. So what is the class mark between 50 to 59? So how do we do that? Roman figure 4. Class mark, popularly called X, between for the third class is 50 to 59. So my class mark will give me is simply 50 plus 59 divided by 2. If we add up, that will give us 109 divided by 2. So let's divide 109 by 2. That will give us the class mark of the fifth class. 109 divided by 2, that will give us 54. That will give us 54.5. So this is the class mark of the third class, which is 50 to 59. The Roman figure 5, so it's the lower class boundary of the fourth class. Who is the fourth class? The fourth class is 60 to 69. So let's determine the lower class boundary of the fourth class. So let's come to our table and determine the fourth class. 1, 2, 3, 4. So the fourth class is between 60 to 69. This is the lower class, while this is the upper class. But they're talking about the boundary of the fourth class, of the lower fourth class, the boundary. So what is the boundary? There's a concept used in doing that. For you to get the boundary, for a whole number, we have cases of whole number, we have cases of decimal. For a whole number, you subtract 0.5 from this, then you add 0.5 to this. So if I want to determine the lower class boundary of the fourth class now, my interest is on 60, because 60 is the lower class. Because it's a whole number, I will deduct 0.5. So the class boundary will give me 60 minus 0.5. That is now 59.5. That is the class boundary, lower class boundary of the fourth class. So let's go to Roman figure 6. Say the upper class boundary of the seventh class. So let's determine who the seventh class is. I will count 1, 2, 3, 4, 5, 6, 7, which is the last number. We are asked to determine the upper class boundary. This time around is the upper class. Is the upper class boundary of the seventh class, which is 99. Like I said earlier, you subtract 0.5 from this, you add 0.5 to this. So let's see what we'll get. Roman figure 6. Upper class boundary of seventh class. So principle say we should add 0.5, which is 99 plus 0.5. That will give us 99.5. That will give us 99.5. Simple as that. So let's go to the next question, which is Roman figure 7. It says the relative frequency of the first class to 3 decimal place. So what is the first class? What is the frequency there? The number of students represent the frequency is 140. That's the frequency of the first class, which is 30 to 39. So what is the formula of relative frequency? Roman figure 7. ROF, which is relative frequency, is the frequency of first class over total frequency. So what is the frequency of the first class? It's simply 140. What is the total frequency? We have to add everything here, but fortunately for us, they save us the stress. The number is given to us as 330 students. That is the total number of students who participated. So my relative frequency now is simply 140 divided by 3300. So what would that give to us? So I'll simply divide 140 divide 3300. That will give us 0.0404 to 2 decimal place with 0.04. The Roman figure 8. Let's see what the question says in respect to Roman figure 8. Roman figure 8, we are asked to the percentage of students who study statistical method for at most, please take notes, at most 59 minutes. So remember we saw what you said earlier, at the time, this time of study was measured in minutes. So we have 59 minutes is here, at most 59 minutes. At most 59 minutes, it started from the least time to a maximum of 59 minutes. So what is the total number of frequency of students who read at most 59 minutes? Meaning from the least to the maximum point, which is 59 minutes this time. So I will get the total number of frequency or total number of students who did that, which is 140, 460, and what? 580. So let's do that. At most 59 minutes. So what is the number of students there? 140 plus 460 plus 580. If we sum up, what are we having? 140 plus 460 plus 580. That will give us 1,180. 180 students. So what is the percentage now? The percentage of at most 59 minutes will be 1180, which is the number of students that did that, over the total 3300 times 100 over 1. That's what we have. So I'll multiply 1100 times 100 divide 3300. That will give us 35.76. 35.76% of students study for at most 59 minutes. So, question 9, percent of students who study for at least 1 hour. At least 1 hour. At least means from the minimum time is 1 hour to the ending, at least 1 hour. 1 hour is equivalent to 60 minutes. 1 hour is equivalent to 60 minutes. So at least 1 hour, meaning from 1 hour to 99 minutes, from 60 minutes to 99 minutes, because 1 hour is equivalent to 60 minutes. So I'll calculate the number of students who read from 1 hour to the last hour there, which is from 60 minutes to 99 minutes. That will give us that Roman figure 9. So Roman figure 9, the number of students, the number who studied for at least 1 hour, which is equivalent to 60 minutes. Which is equivalent to 60 minutes. So how many students did that? Is 1760 plus 760 plus 680 plus 620 plus 60. So if you add up, what are we having? 760 plus 680 plus 620 plus 60. That will give us 2,120 students. That's what we have. So what's now the percentage? The percentage now will give us the number of students, which is 2120 over the total we said earlier, 3300 times 100 over 1. What is that giving us? So times 100 divide 3300. That will give us 64.24%. That is, students study for at least 1 hour. And the very last question here for the day: percentage of students who study for less than half an hour. Half an hour is simply 30 minutes, which is 1 over 2 times 60 minutes. 60 minutes is 1 hour. That'll give us 30 minutes. So fix that. Please help me to put the answer to that Roman figure 10 on the, help me put the answer to Roman figure 10 on the comment section. See you in our next video. Thank you.